In 11.5, we start diving into more specific types of sequences. So I know that sequences are functions. They are functions, so I have an input and output, and the input is typically starting with 1, 2, 3, 4, 5. So that's my domain. We start at 1. And those functions may multiply, or they may add, or I may raise things to a power. So there is a pattern. With arithmetic sequences, I have what is called a common difference. So here's the definition of an arithmetic sequence. The difference between consecutive, that means terms in a row, consecutive terms, is constant. So we have what is called a common difference. We have a common difference. And this will be denoted, which means it will be written as, this is the D that you see in the formula that we will be using. So that means if I were given this sequence, or this list of numbers, 0, 7, 14, 21, 28, if I were given this series, or this sequence, sorry, you're looking at the difference between those two. What do you do to the first term? Well, you're adding 7. Every single time you are adding 7. This is arithmetic. If you are adding consistently the same number, so if I were to put the last term, and I were to make it 30, and then I'm adding 2, this is not arithmetic. If I take away that last term, this is arithmetic. So that means my common difference here is 7. It's a positive 7. If it were to decrease, it could be negative. This is what you guys are going to think of as kind of your slope. It's the constant rate that you're increasing by. So that is how you determine if a sequence is constant. If it's constantly increasing or decreasing by the same amount, that is your common difference. So that determines if it is arithmetic. So here is the formula that the book gives you. A sub n equals a sub 1, so your first term, plus n minus 1 times your common difference. However, the formula that I gave you in class looks a little bit like this. Alright, so there are 4 unknowns in this. However, we have our common difference, and we'll be able to find kind of b, which this should be familiar and look like y equals mx plus b. Alright, so let's look at a couple of examples. For example, I'll do 2 that look a little bit different. Alright, I have this sequence right here, and my goal is to find a sub 9. Alright, so I need to write a rule. I need to write a rule with as much information in there as possible. So I need to find my common difference, and I need to find my b. This is going to be kind of your x and y, so you're going to leave those in your rule so that you have a place for an input and an output. Alright, so let's look at here. What happens? Alright, 20 to 18, you're subtracting 2, subtracting 2, subtracting 2. Alright, this does work out. It is arithmetic, and your common difference is negative 2. So thus far, I can put in negative 2 for D, n plus b. Okay, so now I need to sub in, use these pieces of information and sub in some values. Alright, well, I do know that a sub 1 is 20. A sub 1 equals 20. So that means n for n, if I put in 1, then I will get out 20. So this will help me find my value of b. So I'm going to go ahead and multiply negative 2 times 1, get negative 2. And I'm going to add 2 to both sides. b equals 22. Alright, you can use the formula that the book gives you. However, there will be a couple additional steps. Alright, so we have a value for b and a value for d. That means here is our rule. A sub n equals negative 2n plus 22. And then our final goal right here is to find what a sub 9 is. A sub 9, wrote that backwards. Alright, a sub 9 equals -2 times, we are putting in 9 for n, 9 plus 22 equals -18 plus 22 equals a positive 4. So a sub 9 is equal to 4. And another example that might involve a little bit less work, because you don't even have to identify your first term. Alright, a sub 11, this is example 2. A sub 11 is equal to 24, and your common difference, I don't even need to find it, they just give it to me, is 2. So into my formula, my y equals mx plus b here, a sub n equals, this is my slope, all of these graphs should look like lines, right? I'm inputting 2 in for d, and I do have a sub 11, so if I put 11 in, I will get an output of 22 plus b. Alright, 22 equals 22 plus b. That does mean b equals 0. So what is my a sub n? Well, since b equals 0, I don't even need to put that in there. 2 times n. This is my rule. So if it asks you for a rule, then you should give me something that looks like that. You should give me always something that looks like y equals mx plus b. There will be a slope, there might be a y-intercept. Alright, but I'll talk about that y-intercept sort of situation here. In order to graph these, I need a couple points. I might redraw that a little bit. Alright, so if I have a sub 1, a sub 2, a sub 3, that should be enough for me. If I have my input as 1, that means my output is 2. If I have my input as 2, that means my output is 4, 3, 6. So 1, 2, 2, 4, and 3, 6. Alright, I should get a line. Now let's talk about that domain. The domain does not equal 0. Alright, 0 is not in our domain, even though our y-intercept, our b here, is 0. 0 is actually not in our domain, but we could draw a nice, continuous line. I just need you guys to know that 0 is not actually a point we're going to be using, because I have a first term, I have a second term, I don't really start counting at 0 for these.